So, Asutoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityurma Amritam Gamaya. So, with this prayer for leading from ignorance to truth, from darkness to light, and from death to immortality, IIT Kharagpur welcomes all the participants heartily to this 7th Weekend Talk series. There's an announcement before we start that COE SEA is jointly organizing an international conference on maintenance and intelligent asset management with 3 verticals: asset management and systems, reliability, availability, and maintainability, and maintenance management, and safety engineering and analytics, security, risk management, and human factors. So the date is 12th to 15th, 2021, and the deadline for abstract submission is August 5, 2021. Organizers are Federation University Australia, Asset Management Council Australia, and COE SEA, IIT Kharagpur, and others. So with this announcement, we start the 7th Weekend Talk on Safety Engineering Management and Analytics. So this Weekend Talk series is conducted on 8 p.m. on every Friday and is a very passionate and successful event of the Center of Excellence in Safety Engineering and Analytics of IIT Kharagpur. I am Mom Mitra from Tata Steel, the session moderator, along with Sinjana, Souvik, and Ashish, the research scholars from IIT Kharagpur. So we would now invite Professor J. Maiti, Chairman COE SEA, Professor O.B. Krishna, convener of the Weekend Talk series, and our esteemed speaker of today's evening, Mr. Virendra Kumar Verma, to the virtual dais. So, Mr. Virendra Kumar Verma is renowned industrial safety expert in the country, having served at most of the Indian great companies. He started his career as researcher at CSIR NML, Jamshedpur, and had several publications in the International Journal. He later moved to industries and worked at steel melting shop of Usha Martin Industries, which is now part of Tata Steel, known as TSLPL. He joined Tata Steel in 1992 when Environmental Management Department was getting established. He contributed significantly to Tata Steel's goal on environment-friendly process optimization. He moved to safety function in 2001, and he was the brain behind the safety system evolution in Tata Steel under Dr. O.B. Krishna. It was his initiatives that Tata Steel established the Process Safety Department in 2007, and he was its founder head. He later moved on to Vedanta Aluminium Limited as Vice President, Safety, Health and Environment. He later served also as a Senior Vice President and Corporate Safety Head for Ultratech Cement. And after that, he was elevated as Joint President and Group Head Safety for the entire Aditya Birla Group. He was responsible for safety of all their operations and plant across 36 countries with more than 1.65 lakh employees. He's currently working as the Joint President and Group Head Safety with Adani Group. And we should be saying that he has saved many lives across various industries during his career. So he was also one of the key members in designing the course on industrial safety engineering with special focus on process safety for Tata Steel officers, along with Dr. O.B. Krishna, Dr. J. Maiti, and the current IIT Kharagpur director, Professor BK Tiwari, during 2008. So, ladies and gentlemen, we are very blessed to hear him today on the 7th Weekend Talk. So, we welcome you, and we hand over the session to Professor J. Maiti to formally welcome our expert speaker. Sir, over to you.
So, BK, you see, during my time only, we brought BK to safety function, and he is the brain behind safety excellence journey along with me when we brought DuPont, and all the initiatives which Tata Steel had seen is seeing now, and yet Tata Steel had become excellence in safety. A lot contribution of Mr. BK Verma goes. And especially in the process safety, when we want to get into process safety, Tata Steel, after achieving quite a lot in the cultural safety, so DuPont has suggested, and we have also decided, yeah, it is time for get into process safety. And under the leadership of Mr. BK Verma, the process safety initiative we have started, and we have successfully driven it, and including getting IIT into the platform, also one of his ideas. And he, the the process safety course developed by IIT Kharagpur is in line with what MIT has developed for British Petroleum to train their officers on the process safety after the major incident in 2005 at Texas. So when the inquiry committee has told BP to go to MIT and start a process safety course to bring back their officers to think more on process safety. So that the learning we have taken, and we have started in IIT Kharagpur, where Mr. BK Verma's contribution is good. So seeing his contribution in the corporate safety of Tata Steel, so many industries wanted him to help. That is how he moved to Vedanta Group, and he had shown the same initiatives at Vedanta Group to lift the safety level to next level. And Vedanta Group, he did a great job. Once people start doing good job, and the whole world will look at them, that is how he has been picked up by Aditya Birla Group. And Aditya Birla Group, I am also we are connected from DuPont also. So Mr. BK Verma's contribution in Aditya Birla Group is well noted, not only in the Aditya Birla Group, but across the world, because Aditya Birla, they have got industries across the world. So he had moved from national level to international level. Now, with Adani Group, I need not tell you the importance of Adani Group. Very fast moving private sector in the world, many countries, in many areas, ports, minerals, aerodromes operation is one of the highest, one of the best, one of the leaders. So he is contributing in the in the Adani Group in a very big way, and I wish BK Verma's talk today on process safety performance indicators with a very interesting topic. And being a man from industry, whatever he speaks, that is implemented. The one what he had done, he is going to speak. So viewers can take the benefit of his experience, and you can post all your questions in the chat box, so that from uh, from the academicians, you'll get a different flavor. From the practitioners, you'll get some other flavor. As I told, we are trying to blend the talks from the leading academicians and leading practitioners in the safety and analytics field. So this talk by a practitioner we had implemented in safety in many big renowned corporates, and what talk now where the world is talking about the safety practices in those industries. So Mr. BK, I welcome Mr. BK Verma. Actually, Professor Maiti should have done this, but Professor Maiti is technically he is separated. There's some issue, so it's up to you, BK.
Thank you very much, sir, Dr. Obi Krishna, Professor Mathi, uh, and Professor Tiwari. So first, I think I would like to congratulate all of you for establishing this wonderful Center of Excellence on Safety Engineering, and it will be going to be a big platform in India, because I think it is the first IIT to do this, and it is going to help across the industries to get the expertise, share the best practices, so that across the industry we improve, across the country we improve safety in the industries. It's a really great initiatives, and all of you are top doing for this kind of study in India. I would like to also thank you for inviting me to share my thought into this particular topic on this safety performance indicator on process industries. Just let me share my PPT if I can do that. Thank you, thank you, thank you very much. Thank you, ma'am, for initiating this process. And as you know, I spent almost 17 years Tata Steel, and it's a great to get connected again with the Tata, Tata Steel members. Coming to this particular topics, I think when we talk about the safety performance indicator, actually when you go by the actual facts, these are actually the operational performance indicator, because safety comes later, and the process sustainability matters a lot. If we look into the kind of indicators there, and process industry as such, if you see, those handling the hazardous chemical or hazardous material, be it toxic or corrosive or flammable, are having inbuilt process risk due to many complexity of the process steps requiring high level of engineering design capable of mitigating those major deviations, preventive and predictive maintenance, skilled and competent human manpower. Many of those, their sustainability process requires identification and monitoring of critical safety performance indicator, or performance indicator, or you say operational indicators, because which helps management to know the current status of operational integrity, and also prevent catastrophic failure, loss of control. Ultimately, the idea is that how do we achieve, zero harm, or we avoid any major loss of control. And there are many enablers, but fundamentally you need to have a reliable structure, components, your competent people, processes, systems, which are run by the competent persons. And there are, I mean, numerous industries examples we know, which has those particular cases has shown that how does this performance indicators, if they fail to recognize, they fail to understand, and they fail to take action onto the devices, can lead to the catastrophic disaster. And the examples are numerous. The Jaipur tunnel fire, gas pipeline fire for Gas Authority of India Limited in 2014 in Tamil Nadu, where 32 people got killed. Even Kalmai, everybody knows about that. In fact, very recently, I know about this ONGC Hajira, gas plant, where suddenly in the morning of 3 o'clock on 21st September, there was a huge blast and fire. Fortunately, nobody got killed. But if you look into the details of the failed mechanism, or how do it came out like they were started coming out and started fire and explosions. So these are something which teaches us and the industries that the moment you fail to recognize uh, recognize and take necessary action onto those deviations, it is going to not only kill the people, it is going to there links the entire plant across. I mean, it is on the survival of the industry that how do they I'm sorry, understand those performance indicator and what kind of seriousness they have on to taking action onto that. When we talk about process industry, whether it is continuous process or it is batch to batching process, those processes having the kind of hazardous chemical or materials are getting handled. This is applicable for both. I will tell you in the organization where I'm working, we have many batch processes. But the kind of performance indicators we have fixed, and the way it is getting monitored or it is getting acted upon, the kind of automation we have done. So it does not matter whether this process is continuous or batch. The kind of seriousness are all the time same. In fact, those who are having in the batching processes, they are more exposed to them because you do not know what has happened in between when the second batch is coming up or third batch is coming up. What kind of conformity in the raw materials and the process parameters are there? So I see more danger in terms of batching processes, process industries. There are a lot of examples, like I said, petroleum, chemical, ferrous, non-ferrous. Every industry has its own issues, its own way of monitoring. But the idea is how do you really look into those parameters. That is what the topic of discussion today. And then we go back and see. Particularly, I will tell you this is how I depict the entire processes. If you look into this particular box, sorry, if you look into this particular box, all the industry will have a three system. The first is the primary system. If you look into the primary system, generally these are the system which is operated by the or controlled by the operator. And the primary system will have your measure output, measure input, and measure output. In between, you have raw material, technology, equipment, and all. And the output is the value added product, whatever the process intends to take out. In between, you have assets. So, how does the assets are designed? How does the assets are managed? These are actually not the responsibility of the primary system guy, the operators. So primary system look into how does the secondary system provides those infrastructure and the maintenance practices into that. So it will have, like if you see in the diagram, you have a process control system, alarms and interlocks, safety instrumented system, physical and community safety procedures, the people involved in those, their competencies, and the auxiliary output can be, the accident, loss of control, loss of containment, quality defects, health issues, pollution, community, adverse impact on the community. But if the secondary system works, when we talk about the secondary system, say asset integrity, how does the asset integrity is maintained? This is again coming out from the performance indicators. How does this asset design system, mechanical integrity, quality assurance are maintained? How does your predictive and predictive maintenance systems have been designed? How does the drawings are made updated and made available? How does the process control and management of controls have been done? Process engineering, safety systems, safety SOPs, how does those daily factory tools help the people to know what are those deviations which is happening. The other very important part is that how does the people's competencies are getting looked into, because sometimes when the HR process is not proper, when the selection is not proper, you have a lot of problem in spite of your highly dependable the assets and the processes. The competency of the people is very, very important factor to maintain that kind of efficiency in the this process plants. So the way the HR processes are there, how does the people are put on board, how does this competency and training programs are being done. That is also playing a very important role in the successful or efficient you know, working of the primary system. And above that, there is a very important parameter or critical factors which also is the tertiary system, where the leadership role is there. How does the leaders are demonstrating their commitment? Nowadays, when the people have looked into and have faced those kind of serious safety concerns and those incidents which has built up the many industries, how does the leaders are learning from there, and how does their seriousness on those parameters, their monitoring and spending room into those divisions, the way they understand that makes or that sets the ball rolling, that how does those process industries are capable and making their process efficient as well as making it sustainable and sustainable without having those potential for serious injuries or impacting the community. So whether it is strategic planning, finding the objective review mechanism, risk management processes, resource management. I will tell you during my different organizations stay. I saw some of the people have a very sentimental attachment to the loss of life, that if one person die, how does their families are surviving in life. But see, the kind of media is there now today. Again, for one loss of life, the kind of media attention it gets, and it immediately impacts your sale value. So even if with slight impact in the market, even if somebody loses 5 rupees per share, and you can understand the kind of billions of rupees are lost in a single incident having those kind of things. And if we talk about the process incidents, the impacts on the market is immediately within 4 hours you will see that, and the loss is hundreds of millions of rupees in a single day. So I think with the current scenario, current media attentions, the film system is also become very effective to understand the importance of working on to these performance indicators, whether it is safety or, because I think it is not on safety, it is more on the sustainability of the businesses and the processes. So when we talk about in terms of process industries, I see there are 6 dimensions of safety in process industries, like safety management systems, safety instrumentation systems, aging plants, overall protections and containment systems, competencies, international emergency planning. So, failure of any compliance to any of these dimensions result into very high consequences and sometimes catastrophic impacting human lives, environment, and the property as well as communities. These dimensions are translated into safety performance indicator for identifying the early warning of process incidents. I'm going to describe each one of these dimensions separately. Like for example, when you look into the AV plants, there are industries, they have not modified themselves, and they have not corrected those plant and machinery and technology to meet the current requirement, and they are in trouble. I mean, if you know, Tata Steel was established in 1907, and even I don't think there is even a single, except blast furnace A, there is not even any other plant which is continuing from there. So at every plant they know that what is the life of those plants, and they replace. They have a continuous planning for modernizing those plants. So those organizations which are having the aging plants, and whether they are looking into those kind of, because in aging plants with the old equipment, machinery, outdated technology, you have a bigger risk.
BK, 1 second. One
Yes,
second,
please.
please adjust your mic modulation because people are telling audio is not clear. So adjust your modulation distances and
Okay,
speaker.
okay. So what I was trying to say is that in the aging plant, this is one of the critical dimensions in the process industries. In the aging plant, you have a lot of problems like corrosion, stress erosion, physical damage, expansions, contractions due to thermal changes. Uh, how does the organization is tracking those critical parameters? I remember I will tell you like when I used to be in the earlier organizations, and they had a lot of chemical plants, chloralkali plants, and they were actually struggling with the mercury sale for chloralkali plants, and there were huge issues of mercury contaminations and lot of wastage. I mean, and there are a lot of environmental issues were attached to that. Now, when they move from mercury cells then to the membrane-based technology, and then it's huge. I mean, they use that impact of environment was taken out. The people were very happy. So, how does the organizations are taking those consideration in putting the processes better in operational excellence and also ensuring that the safety and occupational related health as well as the community is taken out. Many a times, even the aging plan with the management is eager to continue. How does the condition monitors are happening across? So this is one of the important dimension of how does management be looking into the aging's critical parameters and what are their planning for working on to those. Second is about safety management system. I think everybody knows about the requirement of safety management system. For me to management of change is one of the important parameters which many times people do not understand that. And I think there are many incident in the industries which has all the time focus upon the necessity of necessity of integrity of management of change. In fact, initially when I was talking about the Surat, the ONGC Hazira plant explosion, that was one of the failure of the MOC because when they put the O-ring of in one of the flow meter and it was a locally made O-ring and they thought it will work, but it failed and then that was a huge exposure which caused those issues. I have seen I have experienced another incident in one of my organization when there was a chlorine pipeline was a problem, and they asked the contractor to change the pipeline, and I think it was 1st of October in 2015, science perhaps, and the contract and the second 2nd October was a holiday. So everybody was in hurry to finish and hand over the plant to the operator. In a hurry to do that, they take out the pipe and also change the O-ring. Now when they issued the O-ring with the particular specifications, the storekeeper gave those O-ring and the contractor fixed and say to the operator that now it has been done and please operate. So they have opened that, chlorine and then people left for their home because next day is the holiday. And suddenly there was a chlorine leakage from that particular pipe. It started leaking like anything. It crossed because of the wind direction. It came on the road and there were two truck drivers who were sitting on over the trucks. They got impacted. Then there was an auto which was going on the main road, and the auto had a 5 or 4 passengers, and the auto drivers they started coughing, and they actually the auto toppled, and everybody was on the road. There was another tempo which came on. They also faced the same chlorine exposure, and they also the auto toppled and then the people were on the road. I mean, I can tell you there were 17 lost time injuries cases. They were hospitalized. One of the drivers died because of the heavy exposure to it. But it was only failure of the management of change because nobody has seen whether those o-ring was really meeting the specification whatever it was sought. During the investigation, we came that that particular o-ring which was given to the party for fixing it, that was similar to the what they need, but it was not the same because at the storage area, both the kind of o-ring got mixed. And while issuing that o-ring, the guy has not able to, the storekeeper was not able to distinguish whatever he is giving, is it matching the same or is it just looks to be same. So, in the safety management system, management of change is a very critical parameters, which is very important for sustenance of the processes. Then there are process hazard assessment, of course, PHA, what we say, mechanical integrity and quality assurance. There are many parameters attached to those. PSI, process safety services, quality
Sorry,
of
excuse me.
yes,
Sir,
please.
sir, actually, a lot of messages are coming as audio is unclear. So we are also feeling some disturbance, sir. So is it possible to use headphones actually? I think that may
Let me
solve the problem.
let me just try. Let me try.
Okay, okay, sir. Okay, sir.
Actually, headphone will give a lot of help in this. When I was not using headphone, these problems people used to complain. Now when I started putting headphone, my voice clear, mom?
Your voice is clear, sir. Very clear.
Okay.
Let me just check whether it is possible.
Yeah, okay.
Is it okay?
Looks to be okay. Go on.
Better, sir. Better.
Okay.
You don't have mic to your headphone?
So it has a mic there.
Okay.
Hopefully not better. So I was talking about those parameters under the safety management systems. Contractor safety is another part of the entire process. PSSR. I mean, these are very common, part of those safety dimensions in the process industries. I'm going to the next part of it, which is emergency planning. Particularly in the process industries, this particular topic is very, very important because how does we develop internal emergency plan, covering all the potential emergency within the site? How do we simulate those emergency scenario and ensure their effectiveness to the models? And how do we update and validate the emergency plans? There are many good examples where the management or the organizations were successful in managing the emergency within the own area, within the own resources. However, when we talk about the external emergency planning, how does organization develop with the neighboring industries and local authorities, covering all the potential emergency within the area, and simulate those, affecting to ensure that how does their effectiveness are checked through the model. However, if you look into the details of the industrial scenario, there are many, Bhopal was the one where people were unaware about what is happening, what will happen if something goes comes out from the plant. There are many ammonia leakages in the industries. Recently we had that LG polymer gas leak where styrene has leaked. Nobody was knowing actually what can go wrong if something comes out from there. So it is very, very important that how does the industries are making the surroundings or community knowledgeable and aware about what can go wrong and would be their access if something goes wrong. So this is another very critical part of safety dimension in the process industries, which as an organization, we need to look into that. Uh, the safety instrumented system is very critical internally in terms of reliability of the entire river instrumentation systems. The safety instrumentation systems are used to monitor the condition of the values and parameters of the process plant within the operational limit. It is also how does those interlocks are effective, how does those, depending upon the risk involved, the management has inbuilt provided those safety integrity level instrumentations, because the SIL one is the cheapest and SIL 4 is the most precious kind of system in place. How does management is uh, serious about the kind of money involved into putting the SIM level? I have personally seen that if the organizations are, highly oriented towards their the risk involved in the processes, and how does it is going to take away the entire operational part, or whether it is so important to ensure the sustainability of the processes. So they put money, but actually, how does as engineers these are being identified as a critical process risks? People do not, nobody wants to spend extra money into this unless they understand the consequences and how does it is going to impact the entire operations. One of the example is another, just I said about the LG polymers, the refrigerant system failed, and nobody took cognizance of those, that how the importance of not functioning of the refrigeration system, and it led to the so many people got killed and so many people got impacted because of that. So how the idea is that how do the engineers are able to communicate to the management about importance of putting money into ensuring that there is a high level of instrumentations provided with the correct level of integrity. That becomes very, very important part of safety dimension in the process industries. This is another important dimension in the process industry. How does the overfill are being critically monitored? Most common process safety events are linked to the overfill, which has a very high potential for fire, explosions, environmental release, and these are very common. Common in terms of a lot of deviations are there. In fact, the Texas, the Indian oil, there are lot of examples are there in India also, where this overfill has initiated the process revisions, and then there was a ignition source, and then the entire thing has gone up. So when we talk about the overfill, there are different mechanisms. How do we, as a management, we provide those automation control into that? Like when we're talking about here, here there was a manual level controller. People are supposed to see and go up, see how much, what is the level, then come back, and then they close the valve. Then they started with some manual and some automation control. When we look back, there are many industries, they are going for automated control so that it is not on people dependence. But however, what kind of redundancy we are providing those systems that even if one sensor fails, how does the other systems are able to take care of that? So this is one part I think the organization has to work upon. And because basically this comes in when at the design stage, when the process hazard analysis are being done before the order is finalized. So what kind of automation control you wanted to have, and what is the reliability of that? What are the redundancy in the systems to ensure that if the one system fails, the second system works, and when the second system fails, the third system works upon. So these are another very important dimension into eliminating those kind of process regressions and the risk to the people and the communities. The next topic is about the containment system. The containment, I mean, the loss of containment is another reasons for many process industries incidents. Generally, when we have a burn that would catch any loss of containment from primary containment, say maybe steel tanks, concrete jackets surrounding the tanks. Many a times, if it is not meeting those processes in place or are not capable enough to contain those particular cases, this in the case of emergencies, it goes beyond and can impact the society and the surroundings. So there are already regulatory provisions given into this that it should be 110% of the capacity of the largest tank, 25% of the total capacity of all the tanks within the burn. But particularly, I have seen in my experience, bonds are only made to show to the people and to the statutory authority about the bonds, but most of the time bonds are not having those kind of capability to hold, in case of the entire loss of containment, primary containment of the particular chemicals or those materials. In fact, if you go back into the industry, the statutory requirement, there are requirements for the tertiary containment lagoons. If you have those kind of facilities, and nowadays the legal things are also there to ensure that you have a tertiary containment lagoons available so that it does not go into the public places. At the same time, those tertiary containment should have impermeable membranes so that it does not penetrate to the ground. The other important factor which I said initially is that how does you have your competency driven process in place so that people have the knowledge and they have the ability to convert those knowledge into the practice. And we have worked upon, in the different level of competency depending upon the hierarchy of the organizations. Like when we talk about the particularly chemicals and the other processes, we have many batch processes in place. So we have put those competency assessment in the functional area of competencies, and we have defined that way level 1, level 2, level 3. And in each of those, we have defined those what would be their level of understanding when you talk about the chemical reactions, the compatibility of the chemicals, the material safety data sheet of the hazardous chemical, the process equipments, what are those deviations which mean for the processes in place, and how does they would react to those deviations if they are able to identify. I think one of the good example I remember on this process equipment division is about the Bhopal tragedy. All of you know about the Bhopal tragedy, what has happened and how it has happened. But when I remember, the video from Chemical Safety Board when it started, and the chief supervisor when they were monitoring the pressure into those MIC tanks, the first identification they did is that they saw that all the pressure gauge of all the three tank were showing negative pressure. Though each of those tank were with them supposed to have a positive pressure, and the guy noted down in the logbook that all the MIC tank pressure gauge are showing negative pressure. If the engineer would have reacted onto that, actually it was shown later on in the video film that in the logbook the engineer has noted down that okay, noted it, and we will remove all the three pressure gauge in the next shutdown. Means that nobody understood that all the three pressure gauge showing the negative pressure is actually showing that the system has gone a negative pressure. If they could have maintained the positive pressure by putting the nitrogen there, maybe the washing water would not have entered into the MIC tank, and whatever would have been the case, but this would not have led to the coming of the fumes to the stack. So, how does the competency of the people are there to understand the duration the process equipments, and do they understand the PID diagram, and do they understand what action they have to take in case of any deviations? Because sometimes the instrumentations do their work, sometimes they do not do their work. How does the people interventions can control that? We have seen lot of cases where the pressure higher than highest, the PRV has not worked. Recently, I have seen one witness that the PRV it has its own design on the PRV, and during the construction, the guy has put the cut GI seat in the PRV. So it is not going to have anything with the kind of pressure release into that. So this is one of the competency parameters, that how does people know those process deviations, what are their implications, and what are their actions required when it is going beyond that control. Similarly, about the instrumentation, their understanding at the different level, compliance, know the operating procedures, what are the critical parameters on which they have to take actions when it is going beyond higher than the highest or lower than the lowest kind of things. Similarly, the people's attitude and behavior on those kind of deviations. So this is one of the important parameters of safety dimension in the process industries. Now I'm going to talk about the actual measurement process. About this active monitoring or reactive monitoring, we say leading indicator, lagging indicator. Both the monitoring systems provide you the structured manner for risk control, the barriers, layers of protection within the whole systems. In tandems or they separately, they act as a system guardians, providing dual assurance to confirm that the risk control system is operating as intended, or providing a warning that problems are started to develop. Generally, when we talk about the active monitoring and the reactive monitoring, or the leading and lagging indicators, one of the example is like for when we say, I just gave example of the PRV or PSV. Completion of a testing of PSB, the pressure relief valve, we can say it is a leading indicators. And the number of times the BRV failed to lift the set pressure can be during the testing can be a lagging indicators in the process safety terms. In this particular chart, I'm trying to show you that how does safety performance indicators in the process industries are generally derived from the key process safety dimensions and active and reactive monitoring system, and maybe categorized into two broad categories, as we say, lagging indicator, leading indicators. The safety performance indicators in process industry must be linked to the identified barriers or the layer of protections for prevention and mitigations of incidents. So both of these are having its own significance. Like the lagging indicators are based on the incidents and their losses, maybe retrospective and reactive metrics, but we will talk about the leading indicators based on the performance of key processes, layers of protections, operating discipline. This is forward-looking, proactive metrics, and it help you to prevent, to become into lagging indicators kind of things. And it must be linked to the safety dimensions and identify barriers, layers of protection for prevention and mitigation of incidents. Like if you look into the barriers or layers of protection, we can have a physical system barriers, instrumented system, management system, and can be linked to the plant design and age, as we discussed. Staff competency, we have also discussed about that. Operational procedures, how whether it is adequate, whether all the necessity parameters have been described into that, whether the people have been trained on to they are aware about those kind of user any changes, permit to work, MOC, instrumentation and alarms, plant change control, inspection and maintenance. I mean, these are some of the critical, part of the processes which are linked to those layers of protections. We talk about how does the leading and lagging indicators provide you dual assurance. If you see the reactive monitorings, as you said, the consequence indicators, and but they're linked to the risk control system or RCS system of barriers or layers of protections. So we the entire efficiency is how do we work upon the leading indicators or active indicators, which provides you the important actions to be taken on those deviations necessary to deliver the desired safety outcomes. So, how does we act upon the advanced findings on those leading indicators and try to prevent to become it also reactive parameters of the processes. However, both continue to monitoring both the reactive as well as reactive monitoring system help you to provide you dual assurance that the system is working as desired on the particular risk control systems. How to set the safety performance indicators? This is a particular process, six-step process, which sets that how do you define or describe or identify those SPIs. The first step is establishing an organizational arrangement to identify and implement indicators. Identify what are those criticals for the processes as applied to the individual industries. So it involves involvement of law parliament, appointing a champion, setting up a team for identifying and working on to that. The second stage is decide the scopes of management systems. So select organizational level, identify and define the scope, identifying the incident scenario, what can go wrong, identifying the immediate cause of incident scenario, review performance and non-conformance. So these are something which is given to the team to work upon. And then identifying the risk control system in place, including the layer of protections to prevent accidents, decide the consequence, and the set and lagging indicator. So what would be if it fails kind of things. So what is control systems are in place currently, where it can go wrong, and if it goes wrong, what would be the consequences? So describe the consequences, set a lagging indicator, follow up deviations from the consequences. Those are, in terms of do phase of this, identifying the critical elements of each risk control systems and set leading indicators. So what are the most important part of the risk control measures? Setting the leading indicators, set tolerance, follow up deviations from the tolerance. So like as I said, depending on the process, it can be temperature, it can be pressure, it can be the efficiency of the transmitters, whether it is pressure transmitters or maybe flow transmitters, which are those criticals based on the operations and the process parameters. the fifth is establishing the data collection and reporting system. So how does this is very important part because once you start collecting the data and looking into the trend, it also gives you, the life expectations, the what kind of deviations are there, under different variables, whether it different parameters, maybe different operating conditions, output. If the outputs are different, then maybe the operating conditions may be different, the control mechanism can be different. So the fifth one, depending upon the different variables, it helps you to generate the data and accordingly, deciding on the details of the action plan and all. And the next one is review. How does review the performance and how do you see access on those devices, whether the process capabilities are there to manage those devices, whether when those human interventions were required to manage those devices. So those review will help you to again go back at the stage one or stage two to ensure that those performance criteria are adequate for the individual operation and processes. When we talk about the SPI indicators, this particular triangle everybody knows when we talk about fertility, major injuries, part of the Henry's triangle. However, if we look into the back, the bottom of those triangle, how does the rules and procedures are made adequate, availability, the people are trained, capable based on those requirements that we discussed, and how does the contractors are part of the entire system? Because nowadays, contractors play a very important role in managing the process because almost 30%, 40% operations, frontline operations are done by the contractors. So how does the organization manage those contractor, efficient contractor in terms of their their resources, knowledge, competency, and skill. But when you go back to the process kind of things, it's slightly different from those behavioral part. And how does those process safety incidents are recorded? The process safety events are recorded. Near misses are recorded. Critical process deviations are recorded, monitored, and acted upon. So if we work on to those process incidents, process deviations, and day-to-day, shift-wise, and take a good train to understand what are those deviations are happening. And many times, if you do not, as an organization or even a management, if you do not try to establish those kind of seriousness in the normal way of process deviation, it becomes a huge problem later on. So the people's sensitivity towards day-to-day process deviations must be taken care. That is one of the important process indicators that how does people are serious about those deviations. I will tell you one of the site visit. I went to one of the control room and was talking to the person who was controlling the two, three people there. And I was looking into the control panel. There were some, as you know, when you go to the control room, there are some green lights, red lights, yellow lights, white lights. So I asked the guy that, see, this corner, three lights are continuously yellow. What does it mean? And the guy was, this was, I think it was in Indonesia. And the guy was said, boss, I don't know because since I joined last 5 years, this is continuous yellow. So how does, you make the competency of the people to understand what are those signals which provide you those, how do you infer from those signals and what are those actions which are supposed to be made. Whether the people are aware about that, whether there's a manuals or operating manuals are available to make the people understand. And we know that for the pilot you have a manual for every deviations, every operating criteria. They can directly refer to that. Whether those process safety, process industries in the control room, those manuals are available or not. The another important thing is to understand that what are those layer of protections, how those are effective, whether those layer of protection barriers are independent and clearly identified and referred to understand how does those layer of protections are helping the entire processes. So when we look into the barriers, they must be interdependent. When you talk about the closed systems are designed to physically cope up with the operating pressure. When you talk about the instrumental systems, they are designed to control the pressure within the design limit, or or the temperature or the flow. Additional physical systems are installed to relieve the pressure if the logical system fails to control it. When we talk about the inspection and maintenance system are designed to ensure integrity of the physical systems. The management systems like procedure, competency, performance management, and audits are designed to ensure that all of the other systems work effectively. So how does the layer of productions are doing their work independently? This is another very important performance indicator for the industries. If you look into the details of the potential incidents and how does how what are those correlated or related critical performance indicators are there. Like if you look into loss of containment, fire explosion, environmental release, process units and all. So these are the permits, related permit to, these incidents can be linked to those PTW variations. How does we work upon those like field audit, document audit, permit verifications, non-compliance, critical activity, categorizations on the permit to work. Similarly, audit will help you to read, to understand that how can we help to prevent those kind of incidents. Similarly, emergency response will help you if we do the inspections and do those models. It will help to get ready for those emergency responses. When we talk about process safety management, how does the MOC is working upon, like number of open or overdue MOCs, number of incidents due to failure of MOC, number of MOC raised by non-trained employees, compliance to the PHA. So those process safety parameters help you to link to those lagging parameters. And safety instrumented system, talk about the overdue test failure, bypassing or overriding safety instrumented systems. Similarly, when we talk about another parameters of routine operations, what are the daily shift checks, the starters and shutdown checks, housekeeping audits, industrial hygiene. I mean, they are the critical safety performance indicator which help you to control effectively on those process on operational efficiency. I'll just present you a very simple case study on the process industries. This is something related to one of our businesses because we are the India largest port. So I'll just give you one information that this is a company operates a contract bulk storage business handling at one of the port site, comprising of two separate tank farms, each containing 80 bulk liquid tanks. Chemicals are imported by ship and discharged at a jetty on a canal. Shore side offloading is undertaken by a company personnel, and the chemicals is then transferred to the site via fixed pipelines running across a private field and a small public road. Both sides have road tanked loading gantries. Ship to shore transfer is undertaken via articulated gantries with flexible hose connections with screw fitting couplings. Load tankers filling is fixed on the fixed overhead gantries with some bottom loading using flexible lines. Clients contract drivers fill their own vehicle Both sides are in operation 24 hours a day. All lines between the source and the installations are cleaned and picked regularly, and bulk tanks often must be emptied and cleaned to allow for a change of product because see these all I mean they are very dynamic in nature because today one vessel has come with hydrochloric acid, tomorrow there may be a nitric acid, therefore tomorrow it can be LPG, LNG. I mean anything can happen any day because we are not very sure tomorrow what vessel will come or which vessel will reach at what time. So the entire inputting our process, in our process has to be done in a very quick successions to help empty out unloading of the entire vessel as quickly as possible. Because there are clients, they will be taking out those chemicals within 2 3 days. Then another phase chemical will come, and it may happen that there is a compatibility issue between the two chemicals. So most tanks are mild steel, a site and sit on the concrete basis with outbound for group of the tanks and some individual big ones. There is on-site production of nitrogen and utilities, including a natural gas supply. Naturally used for putting those inert gases into the highly reactive chemicals. Highly flammable, toxic, and corrosive substances are stored on site, like hexane, heptane, gasoline, vials, methanol, caustic, sulfuric acid. See, now on this particular processes, how does we set the SPI? I said the step process we have just described in the slide number 20. I will just focus on the slide step 2, 3, and 4, the clear steps, and we will discuss it. So in a step 2, beside the scope of the measurement system, so the storage tank will be looking into lots of liquid into burns, lot of liquid outside burns, fire explosion, fire in burn, fire outside burn. When we look into the dock line and chemical transfer to storage tank, lots of liquid from the dock line, lots of liquid from the fixed pipeline, coupling, valve, and flanges, fire at the dock side, and from leak in the transfer pipeline, fire in the burn, fire outside burn. When we talk about the road tanker, filling lots of liquid from the road tanker, lots of liquid from the transfer line, fire exposure in the road tanker, fire in the tanker filling area. Similarly, immediate cause of these incidents can be, failure of flexing hoses, coupling, pumps, valve tankage, which can be because of wear and tear, corrosion, damage, pressure, fire, overfilling of bulk tank and road tank, accidental release because of unsecured connections, valve failure, valve left open. So these are the deviations or the parameters which can lead to the bottom of the renal. Beside the scope of the measurement system, we decide into this kind of thing, like wear, what are the risk control system, corrosion, what are the risk control system, damage, what are the risk control systems, overall engine pressurizations, fire and explosion, overfilling, accidental release, emergency arrangements. So we are working on those kind of deciding the scope of the measurement as we talked about the 6-step process into that. And then identifying the risk control system in place to prevent accidents. So what are the potential lagging indicators? We take out those, what are the risk control system and what would be their potential lagging indicators. Similarly, we take out those critical elements. What are the critical elements and what are the potential leading indicators into that? And then we ultimately come to see that how does this dual inference is there. Whatever we have decided in terms of leading indicators for all those deviations and what would be the potential lagging indicators. So and then justifications in terms of performance of critical equipments and similarly for the lagging indicators. So this is how, as a simple case study, or in the entire process, we work on to those performance indicator or SPIs kind of things. By this, I come to my point essence. And anything you would like to ask?
Thank you, sir. The session was very informative, and I believe participants have. So, sir, from the chat box, we have received more than 10 questions, but due to time constraint, we are taking only 3 or 4 questions. Like, sir, the first question is, how do safety performance indicators are evaluated? Yes, sir.
Hello. Yeah. See,
Yes, sir.
as we said about the one of the example case study, that once you decide on to the different parameters based on the potentials deviation in the processes, those are the routine checkups. For example, I can tell you about the like the hose type is the cleanness with the particular tank, what kind of washing have been done, how do we verify that, because as I said, you do not know which chemicals will be put tomorrow after picking out a particular tank. So I mean these are regular indicators which are getting monitored, and the devices are working upon on a case to case basis. Maybe every morning in the meeting it is discussed. The critical devices are taken on as the case may be on the immediate basis.
Yes, sir. Thank you, sir. Now, sir, the next question is there any guideline or standard available which define the validity of a permit? For how long duration a single permit can be issued?
See, there is a statutory requirement of a permit. Permit is always valid for a shift, 8 hour shift, whether it is a day or the A, B, C, whatever shift it is there. Any change in the because the any change in the conditions or any change in the people, because people will come in A shift, the second team will come in B shift. So this handover permit, there cannot be a continuous work permit. The permit is deposited, sent back, and again refreshed permit is issued. I mean, a secretary, you cannot go beyond 8 hours.
Yes, sir. Yes, sir. Thank you, sir. And the last question is how safety integrity level score decided for process industry?
See, it depends upon the potential risk into that. If you do not have much risk, and then people go for the SIL one. But if you are handling those hazardous chemical, and if if the integrity level is very low, it is going to be a very huge risk to the industry and the processes. So depending upon the risk, what kind of chemicals you are using and what kind of, if you cannot control the variations, what will be the scale of those consequences? See, for example, just I will tell you one example to explain that. We had a conveyor belt across in the port, which is taking out the coal to the hopper for loading. And one of the conveyor was taken shut down. It was PLC based, and suddenly when the people were working on, it started automatically. And no, it was supplied by LND. We worked upon that. Then, when we look into it, this was SIL one, and there is no guarantee because the table which I have shown, it shows that what is your probability of failure. If you look into the design, the chart, it shows what are the probability of failure into that. And if SIL1 probability is, 10 to 100, I mean, in those cases, it has the highest probability for failure, or the probability of, let me say, availability during the need. If so, there is a highest probability that it will not be available when the need arises. So SIL describe you to what is your tolerance for deviations, and so the more you are tolerant, it is SIL 1. The more you are intolerant for deviation, it has to be SIL 4. But in between, you have to, because the cost involved is so high for SIL 4, you have to really work upon based on the risk involved.
Yes, sir. Yes, sir. Thank you, sir, for your response. Now I would like to transfer the session to my mom, Mitra.
Thank you, Souvik. Sir, I just want to ask one last question because this is a common question that we always encounter. The question is, sir, that how many work permits should be ideally issued by a person in a shift? Because, sir, in shutdown jobs, we see simultaneously 50, 60 jobs going on. So, is there any legal viewpoint to it, or yes, sir. Yes, sir.
I will tell you there is no legal viewpoint into that. But only thing is how much a person can go verify and then issue the permit. Generally, because I remember Dr. Obi Krishna is here, when the integrated work permit, what is available in the Tata Steel, and where I was the one to design that, introduce first time into that. And I was challenged by the HSF chief that you show me how is it possible to implement this permit to work. And he called me at 6 o'clock in the shutdown and said, "Can you come and demonstrate how do you do this?" I can tell you, I myself have done 16 work permit after validating the entire shutdown process in the morning, 8 o'clock to 9:30. So it is possible for a person for issuing 8 to 10 just only after validating those conditions and applying for the work permits. You cannot give 50 work permit just sitting in the room.
Right, sir. Thank you, sir. Thank you.
Thank you.
Okay.
Thank you very much, ma'am.
Uh, Sir, now we move on to the vote of thanks, sir. So I would request Maiti sir to propose formal vote of thanks. Sir got disconnected by network glitch actually.
Yeah, I miss Professor Matthew's some sentence.
Yes, Vermaji, you are telling something?
Then I was saying that I missed a few sentences initially.
I think. Yeah, Professor Krishna. Okay,
Yeah.
okay.
Yeah, I have one.
Oh, yeah. Professor Kumar is there.
Shall I take 1 minute only?
Please say, please.
First of all, I would like to thank Mr. Verma for a very pedagogic and informative and excellent delivery of a talk on the topic. I have one comments and one small question. I will start with the question like, are you integrating cyber security in your safety processes? Because if someone can hack your chemical plant or any plant, it can create a mess. So, like, are you looking to that purpose?
I could not hear your question, maybe because of some voice interference.
Like cyber security, like you would be implementing data-driven decisions and all. So cyber security is going to be a very big issue in all plants and especially the chemical one you are handling.
We have a very strong cyber security. I mean, there is a strong IT cell available onto this particular systems, and it is guarded, very heavily guarded for all those informations and those kind of things. And I can tell you anything going out or anybody who is encroaching those kind of things are immediately detected. So we have a very strong system working onto those data security. With the kind of with the way Adani Group is moving across, so there are many enemies than the friends.
And also a small comments actually. I liked your example of lead indicators and lag indicators. Actually, 20 years ago, I was working for Norwegian Oil and Gas. on the lead indicators and lag indicators. And finally, our conclusions were just comments. What is the lead indicators for the management? Is the lag indicator for the active management groups like managers and all. So directors were using the lag indicators to define the lead indicators. And at a time, like a mean time failure of a plan can be lag indicator for a maintenance manager, but for the top manager, it's a lead indicator because it's so low. So like it's a very complicated, confusing questions. So we did a lot of work on that area, and it was very good examples. Thanks. That was the some comments. Okay.
No, but I think your comment was very valid. See, I will tell you because I have a particular position where I'm directly interacting with the top man. And I have personally, I can tell you that contributed in, the maybe review of those safety integrity level and the integrity of the processes, reliability system and all, because I could make them understand that this is not a cost. It is going to be a investment for your higher return. And many times we successfully worked upon that, and the people were happy to get those money because it is not very easy to get money onto those kind of things.
Thank you very much.
Thank you very much.
Okay. Okay. Thank you. Thank you, Mr. Verma. Thank you, Professor Kumar, for your excellent question. This is now actually, first of all, I am extremely sorry that internet connectivity is poor today and I was lost for some time. So I'm sorry to every one of you. And Mr. Barma has made our life easier today, and he has made a wonderful explanation with reference to the basics of process safety to ultimately the leading and lagging indicators, and with a case study that how leading and lagging indicators should be identified and then finally used for effective safety management. In the process, he explained also the safety integrity level and the dual assurance systems and other things. It's a very complicated topic, and at the same time, it requires time to understand fully what is there inside. So we are thankful to you, Mr. Verma, for your nice presentation and lucid explanation, particularly in terms of your presentation as well as case study. I'm sure the participants have enriched a lot. All the video lectures are available in the YouTube platform, and the all the links are actually it is under Center of Excellence in Safety Engineering Analytics. If you Google it or you go to YouTube directly and type Safety Engineering and Analytics, and you will be able to see the video lectures. So some of you are posting that video lectures should be available in YouTube. It is already there. So up to 6 week lecture is available, and 7th week this lecture will also be available by 2 to 3 days of time. And we are extremely thankful to the participants, particularly every week we are finding that there are a large number of participants attending the program, and there are many participants who are constantly going through this lecture, and I'm sure that with your active participation, our future lectures also will be able to organize. I have only one request to the participants, particularly I wrote in some other earlier chat box that you please propose some of the topics what you are interested to listen. So some topic like human factors and others that last time we have received, but you can send us email also, and we'll be trying to develop such presentation, and some expert in that line will definitely present in the in near future. So yes, we are extremely thankful to you. I am thankful to Professor Krishna, who is convener, and I don't want to extend by thanking him more, because he is basically the all in all for this program. And
Very
mom,
good.
you are basically doing excellent work along with Sobik, Ashish, Sinjana, the research scholars from IIT Kharagpur. All of your efforts ultimately making these things successful. And obviously, I must thank to the IIT administration for not only for establishing the center in 2020, but also providing all sorts of administrative support and facility for conducting this program. We will be benefited by the feedback of the participant from the participants. Please write to us about also criticize us. So thank you, Mr. Verma. Thank Professor Krishna and the dear participants and the technical team. We will meet again in the next week at 8 p.m. With a topic, with a different topic. Again, in the interesting topic. Professor Krishna, if you want to add
BK,
something,
BK, I want to tell you one thing. The replies, the examples which you have given, it shows the authority which you exhibit on the subject. Though
Thank you.
the
Thank you, sir.
internet is very bad today, but those things, though people have appreciated those examples, because that is what is expected from a practitioner. And you being the implementer of all these things, you have shown your authority. You have shown the authority in your replies and examples. Thank you for this wonderful lecture.
Thank you very much, sir. Thank you, Professor Bhatti, everyone, for giving me the opportunity. It's nice to share my thought process with that. Thank you very much.
Okay, okay. The session is ended today. Thank you.
Many thanks.